Hi everybody, so here is a video to quickly explain this two-column proof. This comes from another proof that we've done before. It is the same as the flow chart. We're proving the same thing, just it looks like a different type of format here. So to remind us of what it is we're proving, we originally started with the diagram that looked like this, where we have A, B, C, and D, given that AB is congruent to CD. Okay. So remember, here's how the flow kind of works. We are going to work left to right, but then also up to down. So everything from here to here should be linked up. As we saw in the flowchart proof, it's kind of like if we have this left to right motion going, your flowchart proof looked like it had one bubble with the statement and your reason all in one bubble. But here we're seeing it as a statement on the left, reasons on the right. And then as we go down, that's kind of like when you take your bubble and go to the next bubble. Okay, so from here, remember that whenever we're going from something that is congruent to saying the same thing is equal, we use this reason of definition of congruent segments. Okay, so we are saying the same thing, but first we're saying that the pieces were congruent, therefore the measures are equal. Whenever we're stating that something is equal to itself, in this case that the measure of BC right here is equal to the measure of BC in that middle, we use the reason of reflexive property. Now, using all of the prior information, we're allowed to go to this step 4 piece, where it says that the measure of AB plus the measure of BC equals the measure of CD plus the measure of BC. This falls under the addition property of equality because we are adding things that we already knew was equal. So that's these pieces right here. And adding on something else that we knew was equal to that. So this allows for our equation to stay balanced. Addition property of equality is just that when we add something of equal value to something that we already knew had equal value, we're keeping equality, right? Next two pieces happen almost side by side because they look the same and they are using the same reason. For here, we are talking about the line segment, the measure of AB plus the measure of BC will equal AC. So seeing how when we add pieces together, we get a whole over here. Okay, that's our segment addition postulate. And then similarly, we have BC plus CD equals BD. So I'm taking this piece BC and adding it to CD, and knowing that if I wanted to, instead of saying BC plus CD, that's the same thing as just saying BD. Okay, they're the same length. Now, using this information, because here is where all of the magic happens, taking a look at AB plus BC. We knew this already from this line up here, okay? And we also knew BC and CD from this line up here. So instead of saying that lengthy piece of ABBC equals BC plus CD, I am now taking and substituting what I know is equal right here and set it equal to the other piece. that I know is equal, right here. So now we have saying that the measures are the same. By that substitution property, we are using that line 4 to substitute into line 7. Going from equal measures to congruent pieces, we're using that definition of congruent segments one more time. So again, now we have this equal to congruent. And that's how we use that definition of congruent segments. So that was that proof to get from the fact that AB was congruent to CD as our given, and wanting to prove that AC is congruent to BD. All right, hope that helped.